So let's start with depth first search. So in the last video I have told you about how to go about BFS. So now we will see how to use DFS basically. So it's another searching techniques in terms of graph, and basically this gives us the result same as pre-ordered traversal in any tree. So if you match the result of DFS, it gives us the same result as we have done in the case of tree traversal, and result will be pre-ordered traversal in the DFS. So if you traverse your search your graph using depth first search, you will get pre-ordered traversal kind of answer, and this is nothing we know. Answer is always sorted. So data, whatever answer you are getting, it is mainly used for sorting technique. So DFS is very much popular if you want to get a sorted kind of data. And third very important point, although it's little bit complex in nature, and sometimes it suffers infinite loop problem also. That's an important point about DFS. So DFS may go into infinite loop, and it is little bit complex also. So but it is very good for large number of vertex. So if you have large number of vertex, let's say, then in that case you prefer DFS over BFS. So if the less number of vertex are there, we basically go for BFS searching, label order searching. But if DFS is there, large number of vertex are there, then we prefer DFS. And one more difference you should know, that in DFS we normally use data structure, that is stack. So as you have seen in the last video, in BFS we use queue as a data structure. Here we maintain stack as an additional data structure. So these are a few important points related to DFS, and there are differences. It is good for this. And second one important point, it's basically a two-stage process. Two-stage means in first stage you will do pushing operation, and in next stage you will do pop operation. So push and pop operations are there. So basically it is two-stage process, while BFS is a single stage process, and you are inserting the data into the queue and simply popping out. So it's a two-stage process, but it's a very much popular in terms of if you have a very complex kind of structures and large number of vertices are there, then you prefer DFS over simply BFS. So these are the few differences you should know before moving into BFS versus DFS. Now we will look into the problem, how basically DFS works. So very simple strategy. Here we'll take one question first. So let's say the same questions we are taking as the example we have taken in case of BFS. So same example we can take. So let's say vertices are like this, and then you have 2 to 5, and then you have 7, then you have 8, like this, 2 to 8, 2 to 7, then 5 to 6 also, and then you have 10 here, and you have 9 here. And this is the structure. Let's say this examples we are trying to solve it through DFS. So where basically you try to understand one thing, that whenever you are trying to solve this kind of questions, we simply maintain additional data structure that is known as stack here, and here we will be writing results of our DFS traversal. So we can start from any vertex. So let's say source vertex or starting vertex we have chosen as a 1. So same you can start from any other also, 2, 4, anywhere. But strategy is that you simply visit the vertex, write it results here, visit and write it results, and then push that particular vertex into what way in your stack. Fine. So these are the two things you should try to understand. I visited one, written my output result, and pushed that node into stack. Okay. Second step, this is the initial step. In the second step, now out of the adjacent vertex 2 and 4, you need to visit only one vertex. You can either take 4 or you can take 2, no issues, but any one vertex out of its adjacent vertex in DFS you have to take. While if you remember in case of BFS, you need to explore this vertex and put all these 2 vertices in queue. But here this is little bit different. Different means you only go with one vertex. Okay. So let's say after 1 I am selecting a vertex 4. So I will select it and push it here. Why we are pushing everything here? Reason being, this vertex 1 or 4 is still not explored completely. So we will come back again. We will backtrack and come back again. Fine. So we will go one by one visited vertex. From 4 you can see where you can go. You can go to 3. So you can first write the result, that is visited vertex, and then push it into stack. Fine. And from 3 again you try, you have two different adjacent vertex where you can go. Let's say I have moved into 9. Fine. So I printed 9 here and pushed that 9 into here. From here you can see, from 9 there is a dead end. This is dead end. It has no adjacent vertex. So once you are reaching to dead end and there is no unvisited vertex out of 9, because 9 has no adjacent vertex, we will try to pop it out, that vertex from stack. So 9 will be popped out. Fine. We will go backtrack to 3. So now 3 is my top of the stack element. We will again resume this 3. Earlier it was suspended. We will resume 3 and we will check for any other unvisited vertex out of 3 adjacent nodes. So from 3, this 9 has already been visited. This is written here, but 10 has not been visited. So we will again write 10 here, result, push 10 onto the stack. Again we will do the same process. Top of the stack right now is 10. And 10 has no adjacent vertex. So I will pop it out. Fine. So 10 will be popped it out. Again we will go to 3. So again 3 is the topmost element in the stack. We will check whether top of the element has any unvisited vertex. Yes, still 3 has a connection to 2 and which has not been visited. So I will push it to write the answer and push it here. Fine. And then from 2 you can understand what are the different vertex which you can access from 2. Either you can go to 5, 7 or 8. So let's say any one of these vertex you can take as a next vertex. So let's say I have taken as 8. So from 2 you can write 8 and push it on stack. Still 2 is not completed. So 2 is below and top of the stack element is 8. From 8 you can go to 5, you can go to 7. These 2 are still not visited. So let's say I have selected 5 as a visited and 5 has been pushed into the stack. And from 5 you can go to 7 as well as you can go to 6. So let's say I am assuming that from 5 I am going to 6 first. Okay, I am going to 6 first. So I am writing 6 and pushing it here. From 6 you can see there is a dead end. You cannot go further deeper and deeper. So we will check for 6 adjacent which is not visited. 5 has already been visited. So we will pop it 6 from here. To pop out 6 from here. Again we will go to resume my 5. Check for any unvisited vertex out of 5. So 5 has a connection with 2, already been visited. 5 has a connection with 6, already visited. But 5 has one more adjacent vertex, 7, which is not visited. So we will write it here 7. So 7 will be explored next. Now 7 we will try to see whether it's all adjacent vertex are visited or not. Yes, 5 has been visited, 8 has been visited. So 7 will be popped. Similarly for 5 you can check. 5 has adjacent with 6, 7, 2, all has been visited. So 5 will be popped. From 8 you can check, it is 2, it is 7, it is 5, 2, 5, 7, all visited. From 2 you can see 5, 7, 8, the 5, 7, 8 all has been visited, so it will be popped out. From 3 you can see it has a connection with 10, 9, 2 and 4. 10, 9, 2 and 4 all has been visited, so it will be popped out. From 4 you can see it has a connection with 3 and 1 visited, so popped out. And from 1 you have a connection with 2 and 4 and both has been visited, so it will be popped out. So finally you see after the second stage of popping operation, all stacks elements are popped out. So that is the condition of acceptance. Means when stack become empty, this way you can say this traversal techniques has finished now. So once the stack become empty, you stop this process and you get your DFS results. As stated in BFS case also, you may have different results in terms of DFS. So DFS may have many answers. Let's say rather than starting with 4, we can start with 2 also. So second visited vertex I can write like 1, 2 and so on. So this answer will be different from my first answer. But both answers are correct. But the process is simply you visit, print in the result, push it into stack. Again, you explore only one. Yes.